Hello from two students. Welcome to our mathematics lesson today. And we are going to look at area of quadrilaterals. This is our lesson number 4. And today we'll look at area of polygons. I'm your teacher, Mr. Wanyeke from Merihiga High School. Welcome. Now, in Form 1, we looked at various polygons, the number of sides, and the number of triangles they have. So we can remind ourselves this table on the names of polygons and the sides they had, because this will be important in our lesson today. You can go through the list later on or now. You can pause and go through the names of various polygons. For instance, an 8-sided figure will be called an octagon. A polygon that has 9 sides will be nonagon or enneagon. 10 sides will be decagon. 11 will be hedacagon or andecagon, and so on. So in Form 1, we worked out this kind of examples or work where you are supposed to use interior angles and exterior angles. Like the angles labeled A are exterior angles, and the other ones that form the supplementary angles of each A is then the interior angles. The exterior angles add up to 360 for any polygon, and therefore you can always get the size of the exterior angle by getting the number of sides of the polygon. Then you have 360, you divide by the number of sides of a polygon. That will give you the size of exterior angle. For example, in this example 1, the sum of the exterior angles labeled A, because they are equal, since the polygon is regular, then you'll have 6 A's, giving you a total of 360 degrees, and therefore 1A will be equal to 60 degrees. In example 2, where you're told to find the number of sides of a regular polygon with an exterior angle of 45 degrees, and then you're also told to name the polygon. Because you have been given the exterior angle as 45 degrees, then yours is to get 360 degrees, because the sum of exterior angles add up to 360. So it is 360 divided by the size of one exterior angle, which in this case is 45 degrees, and that will give you 8 sides. Then the name of an 8-sided polygon is called an octagon. An octagon. How do you get the area of a regular polygon? In order to find the area of a regular polygon, we need to define some new terminologies. First, all regular polygons can be inscribed in a circle. So, regular polygons have a center and a radius, which are the center and the radius of the circumscribed circle. Also, like a circle, a regular polygon will have a center angle formed, or a centroid. In a regular polygon, however, the central angle is the angle formed by 2 radii drawn from to the consecutive vertices of the polygon. In the picture below, the central angle is BAD. Angle BAD is the central angle. Also notice that triangle BAD is an isosceles triangle, because the distance AB is the same as AD, which is equal to the radius of the circle, and which is also the radius of the polygon. Therefore, every regular polygon with n sides is formed by n isosceles triangles. For instance, if a polygon has got 10 sides, then it will have 10 isosceles triangles, because the sides forms the basis of these isosceles triangles. Therefore, in a regular hexagon, or for instance in a regular hexagon, the triangles are equilateral. Why? A hexagon has got 6 sides, and the center angle will be 6 degrees. Then it means that also the isosceles triangles formed are equilateral, and therefore each of these angles will be 60, 60. And therefore, that's why you're told the triangles formed are equilateral. Remember, the height of these isosceles triangles is called an apothem. Is called an apothem. The one, the line drawn in red, or line AC, is called an apothem. Or actually, the perpendicular height of each of the isosceles triangles. For instance, in this case, or in the figure below, we have the isosceles triangle BAD, and the perpendicular height of BAD is AC, the one in red, and it's the one we are calling an apothem. Remember, by the isosceles triangle theorem, the apothem being the perpendicular bisector of the side of the regular polygon, then we can always apply trigonometry to get the area of this triangle. And therefore, in the following examples, we'll be looking at how we can use the area of a triangle to get the area of any given regular polygon. It is important to note that when you're getting the area of a regular polygon, for example, a regular hexagon, we have the apothem, which is in this case labeled letter A, which is the perpendicular height of the isosceles triangle GAF. Isosceles triangle GAF. And remember, we said it is isosceles because it is made up of two radii, that is AG and GF. They are the radius of this circle or the polygon. And therefore, in this hexagon, the apothem is the perpendicular height of triangle AGF. And therefore, the area of this triangle AGF is a half base times height, where we have the base as B and the height is our apothem, which is labeled A. And therefore, the area of this hexagon will be 6 times a half BA. 6 times a half BA. Let us now look at example 3. You are told to calculate the area of regular hexagon of side 8 centimeters, giving your answer to 3 significant figures. In this case, or in this polygon, which is a hexagon, meaning it has 6 sides, and therefore we need to ask ourselves, if it has 6 sides, what is the angle at the center? The angle at the center will be 360 divided by 6, because if it has 6 sides, then it is going to form 6 equal triangles or 6 isosceles triangles. In this case, it happens that this hexagon, because the center angle is 60, and the line OB and OA are equal, or they are the radius, then it follows that the angle at A, that is angle OAB, and the angle at B, or angle OBA, they are equal and they measure 60 degrees. And therefore, triangle OBA is an equilateral triangle. Now in this case, we have the radius 8 centimeters, and therefore OA is equal to OB, which is equal to 8 centimeters. Therefore, also OA is 8 centimeters. Remember, this being an equilateral triangle, it means that the 3 sides of the triangle are equal. And if side AB is equal to 8, then it follows that OB is equal to 8 centimeters and OA is equal to 8 centimeters. And therefore, we can use a half AB sine theta to get the area of this triangle OAB. So in this case, we'll pick 8 and 8, and the included angle is 60 degrees. So we say the area of this triangle is a half times 8 times 8 times sine 60, which is going to give us the total area as 166 centimeters squared. Let us look at the example 4, where now we are given, instead of being given the length of the side of one side of the polygon, we are given the radius of the polygon. You are told that a regular decagon is inscribed in a circle of radius 4 centimeters, and you are required to calculate the area of this octagon to three significant figures. So we know the radius is 4 centimeters, and therefore the length of OA is the same as the length of OB, which is equal to 4 centimeters. And here we can easily get the area of triangle OAB, which will be given by a half AB sine theta, which in this case is a half times 4 sine 36, and that gives you 4.702 centimeters squared. Now this octagon has got 10 sides, and therefore that means it has 10 triangles, 10 such triangles, each of area 4.702 centimeters. So to get the area of this decagon, of this regular polygon with the 10 sides, is 10 times the area of one triangle. So it is 10 times 4.702 centimeters, and that will give you 47 centimeters squared. Let us look at example 5, where you are told to find the area of a regular pentagon with a perimeter of 40 centimeters. Now, for us to achieve this task, we need to find the length of apothem first, so that you can be able to get the area of one triangle. Remember, this being a pentagon, it has got 5 sides, and therefore the angle at the center will be 360 divided by 5. That will give you 72 degrees. And with 72 degrees, we know that the apothem PQ will bisect angle NPM into 2, such that angle NPQ will be half of 72, which is 36 degrees. And we know that if the perimeter is 40, then the length of one side will be 40 divided by 5, which will give you 8 centimeters. 8 centimeters. Therefore, the length of side M or NM is 8 centimeters, meaning PQ is dividing that length into 2, or is dividing the length NM into 2, and therefore if NM is 8, then NQ will be 4 centimeters. With that, now we can solve, or we can get our apothem and hence the height. So we'll say tan NPQ, remember NPQ is 36 degrees, will be equal to opposite over adjacent. And our opposite is 4. Remember, we said it is 4 because it is 8 divided by 2 to get the length of NQ, and therefore tan 36 is equal to 4 over PQ, meaning PQ is the same as 4 divided by 10 tan 36, and therefore the length of apothem PQ is 5.5 centimeters. So now we can use a half base times height, then times the number of triangles we have, or times the length of the sides we have, times the number of sides we have, to get the area. And in this case, the area of the pentagon is becoming 110 centimeters. Students, we have come to the end of our lesson today. I believe you have learned something, and you're going to apply it to do the assignment given in this slide. Ensure that you do your work and do it on time, and upload very clear images to the Google Classroom platform. Have a blessed day.